Alrighty, welcome to Geometry in Construction. The first video of many to come here for Geometry in Construction. It's going to be an awesome year. So we're going to start with some of the fundamentals of geometry here in this first video. A lot of definitions, what's going on, what makes geometry even possible. Alright, we will try to apply as much as we possibly can, as will be tradition, as is tradition in geometry in construction. Alright, let's start with a point. A point. A point would be like this. Hey, there's a point, and we can label it as A. That's point A. Let's say I throw a point B over here. Label it B with a capital letter. Awesome. Look at that. That's one piece of the puzzle. Now, what about lines? Lines. We got points and we got lines. Hey, guess what? If I connect these 2 points, what does that make? Ayo, a line. So that'd be like line A, B. And you pop a couple arrows on it to show that it's a line. That was crazy. I just took the 2 points that we drew and drew a line through it. That's because 2 points determine a line. I'd write that down. That's a good definition right there. 2 points determine a line. Alrighty. And the last one we're going to talk about on here before we get to the next page, you get some room, would be a plane. So we got points, lines, and planes. Alrighty, a plane is just like any flat surface. Okay, we're talking about everything in planar geometry. So when I drew this line over here, right, I was drawing it on a plane. Okay, it's a flat surface, two-dimensional. Alright, two-dimensional geometry is pretty much what we're dealing with here. Obviously in construction, we're going to be dealing in a three-dimensional world, which we all live in. But a lot of the stuff we do is two-dimensional in the geometry side of things. Okay, so now we've got it. Points, lines, planes. That's what geometry is made up of. Those 3 things. Everything else stems from it. Alright, 2 more for you. We got a line segment and ray. So a line segment, if we had, let's say, how about 2 points? So let's say we got D and we've got R. If I connect those 2 points, I've got a line segment. We'd notate that as line segment DR with a line over it, just like that. Okay? No arrows on that one, as it's a line segment. Okie doke. Okie doke. Now we got a ray. Let's say I've got 2 points. Let's call this C and E. Now this right here, if that line goes through those 2 points, it starts at C and goes through E, that's called ray CE. So we'll call that ray CE. Alrighty. Notice how order in this one actually does matter. Over here, this could have been RD, but this one could not be EC. EC would not be the same thing. In fact, EC would be something different, and that's why I drew it in a different color. If I started here and went this way through C, that is EC. Notice how that's different. We start with E, go through C. That's different than starting with C and going through E. Okay, because it has an end point. And then it goes on forever in the other direction. The arrow notates forever. Cool? Now, what happens, you might be asking because you're just curious, what happens if I don't throw anything over the top of it? Let's just say I just had DR. If I just had that, no line segment over it, nothing. What does that mean? This right here is a length. Okay? That's saying the distance from D to R. From D to R, that's what that notates when there's no line over it. Okay, it's the length of that segment, the distance between those 2 points. And we'll get into distance formula at another time. Okay? Alrighty, now we got an angle. More definitions, definition heavy today. Alright, so an angle is made up of 3 points. Let's say we've got A, B, and let's say I've got C over here. So if I were to connect these like so, pop a couple arrows on there, that's important. I've got angle A, B, C. And that order is important only for the middle letter. That is the vertex of the angle. Okay? It could have been angle CBA. That's okay. That would work. However, angle BAC, that's a no-no. All right? The B has to be in the middle. That's the most important part. That's our vertex. Okay? That's the vertex of the angle. That is incredibly important. Now, for this one, I could have also just said angle B. Okay, and the reason why I can do that is because it's the only angle associated with a vertex of B, so I can call it angle B. However, I'm going to draw another scenario for us, all right? I'm going to toss this stuff off to the side. Let's say, for fun, we're going to pretend all that stuff is at one point right there, okay? And I'm going to pop some points on here. Whee! Please forgive me anytime there's not necessarily the most accurate of drawings. It can be a little difficult on this iPad. I'm using my finger to do this all, okay, rather than a stylus. I don't know what happened to my stylus. All right. So I've got lots of stuff going on here. So in this scenario, if I were to say angle E, okay, would you know what the heck I'm talking about? Because I don't even know what the heck I'm talking about. I would have this angle here, or this angle here, or this one here, or it could be this one, or it could be that one, or it could be the whole big one, AED. I don't know. There are so many angles associated with E being the vertex that I just cannot notate it in this way, okay? In this scenario, we'd have to use 3 points, okay? When in doubt, use 3 points to write out the angle, okay? Because I would, if I said, if I wrote down angle AEB, I bet you could tell me which angle that was. This bad boy right here. Angle AEB. Okay? So that's important. Woo-hoo-hoo. Couple more big words. Here we got perpendicular and parallel. I bet you these two are ones you're familiar with, or at least you should be from Algebra 1, because you guys wrote equations of lines, and you wrote equations of parallel lines, and perpendicular lines. Alright? So let's refresh ourselves. Perpendicular, we get a right angle, right? So we got lines, line segments, rays, whatever. They intersect, they form a right angle. Parallel, they never intersect. Okay, so we got a couple lines, they never intersect. And we can actually, why don't we just draw this guy through? Boom. Right angle for perpendicular, parallel, they never intersect. That's pretty much all we need for now as far as these two go. But we'll dive into them a little bit more later with equations of lines and applying them and all sorts of super cool fun stuff. Alrighty, these last three, and we are done for this video, ladies and gentlemen. Okay, so we got midpoint. Midpoint ties into the median here, so I figured it'd be important for us to chickadee check it out. Okay, midpoint would require you to have a line segment of some sorts. So let's say we've got this guy here. We'll call it line segment A, B. And guess where the midpoint would be? Well, it would be right smack dab in the middle. That does not look like a point. Again, this thing's a little tough to draw on sometimes, alright? So we'll call that point M, alright? So that would mean that it splits into two congruent segments, okay? That means that AM is congruent to MB. Okay? You see what that means there? Congruent. Congruent. Look at that. We just threw another definition in here, even though I said there was only 3. Alright, so we got congruent. That means we got the same measure. or same length. So, and the reason why I said same measure rather than same length at first is because angles can also be congruent. Okay, so if this is, say, 60 degrees, let's say this is angle, let me put a point right there, A, and then let's say I've got another angle that's 60 degrees. We'll call this B. That would mean that angle A is congruent to angle B. All right? So congruent can apply to line segments, it can apply to angles, and it can even apply to triangles and other quadrilaterals and other polygons even, okay? Same size, same shape. Okie doke, let's actually jot that down as well. Congruent. Same size, same shape. Alrighty? So that's another way to describe congruent. That was awesome. Now let's talk about median. After all that, that was a little surprise bit of concept there. Okay, so we got our median now. Median just means that it's a line drawn through the middle. Let's go with a triangle here. Let's say I've got a triangle. If I draw a point through the middle of the opposite side from a vertex, let's label this as A and B. That means that AB, segment AB, these guys are congruent. AB is a median. Okay, there we go. It's drawn from the vertex of a triangle to the opposite side, and it's to the midpoint of that opposite side. I like it. Okay. Now, I'm going to zoom this out a little bit so we get a little room for altitude, because I started running out of room after I went on a tangent about congruent there, which is super important. I'll have you know. Alrighty. Last one, altitude. So an altitude is often confused with median. They are different, though. So an altitude needs to be perpendicular when drawn to the opposite side. So kind of the same idea, but rather than being drawn to the midpoint, it's drawn perpendicular to the opposite side, which is why that definition of perpendicular is so important. So let's say it's A, and that's point B right there. All right, where there's intersections, there's points. So we've got AB is an altitude. So altitude tells you that it's perpendicular. If it's right there, and I said that this was perpendicular, right? I was like, oh, hey, AB is perpendicular to this side here, and I could even give it some letters. Call this D. We'll call this C. If I said AB was perpendicular to DC, you could tell me that we've got ourselves an altitude here, right? But from this scenario, you could not conclude that it's a median because you'd need congruent segments to do that, right? Okay. So we'll be using these quite a bit. If you got any questions on them, feel free to ask us in class, and we will try to clarify it. But we'll be using them throughout, okay? Freedom, rock and roll, America, yeah.